First thing I'd like to say is I'd like to thank Todd and Roy for all the hard work they put into putting this together. I think they've done a great job. You know, I think the venue, facilities, organization they've done has been tremendous. So I thank them. Also, I never start a presentation or anything I do without telling a joke. And I'm going to tell you probably the worst joke you'll ever hear. And you'll be telling people years from now about this bad joke. It's really a story. It's a story about a rope. It's just a common rope. And this rope was walking down the street and he developed a big thirst. Now you got to suspend disbelief a little bit here, guys. So anyway, the rope went into a bar and he ordered a beer. And the bartender threw him out. He said, "We don't serve ropes in our establishment." Threw him out. And it hurt his feelings. You know, he felt really bad about that. So he was walking down the street and he ran into a buddy who was another rope. And his buddy said, he told his buddy what happened to him. His buddy said, "Hey, we'll fix that." So he tied him up in a knot and he frayed his ends. Sent him back in the bar. He ordered beer. Bartender served him. And as he turned to walk away from the bar with his beer, the bartender said, "Say, aren't you a rope?" He said, "I'm afraid not." Well, if you've heard a worse joke, tell me after this presentation. Anyway, we're going to talk about Drywash. And one thing about my company, which is a small company compared to you know, a lot of big corporate entities out there, we don't do a lot of advertising. We don't have a big sales force. We don't have a lot of slick brochures. And a lot of people have asked me when I've talked about Drywash, they said, "Well, do you sell Pure Light or do you sell Amber Light?" Well, we don't sell either. We make our own resin. We manufacture. We didn't start out making products with biodiesel industry. We started out making catalysts and products for oil and gas exploration and for chemical processing and refining and for soil and groundwater remediation applications. And I got tricked into getting into the Drywash business and manufacturing a product for the biodiesel industry. Our product, and I think anytime I go to a presentation, one of the first questions is, "Well, this guy, why is he talking to me? You know, what's his experience?" And I can tell you that we've made biodiesel in my plant basically for our R&D, but we're not into making biodiesel, and I don't know nearly as much about you know, the down and dirty, particularly at the home brew or the co-op level, as Norm and Graydon and some of the other folks in the room, those of you that have more experience making biodiesel. But when it comes to Drywash, in the U.S., of the big plants, from 1 million to 30 million gallon capacity, whatever it might be, I don't know of a large plant in the U.S. that does not use my product. I'm sure there's one out there, but I haven't found it. Basically, 90, 95%, 97%, whatever the number is of the Drywash resin that's used in the U.S. is manufactured by my company. And our approach is we're heavily involved with our customers. I've been in not every one of my customer plants, but most of them, and a lot of plants that are water wash or Magnesol process. So I've seen a lot, I've talked to a lot of my customers, and I've learned probably all of the wrong ways to do it. You know, I've seen it. I've worked with folks, you know, in their efforts to make it better. But one of the things I think we need to talk about first is obviously when you talk about dry washing, you're talking about removing, whether you use the word contaminants or impurities or byproducts, whatever you want to call it, you're removing things from the biodiesel, from the methyl ester, to make it either meet specifications or simply so that you can burn it in your truck. And some of the things we're trying to take out are liquids, both polar and non-polar, and solids, dissolved and suspended. And the components in red are things that Drywash resin will remove. And if you start at the top of the list, some people call it glycerin, some people call it glycerol, but same animal. And these, if you see the ones in red, those are the things that drywash resin will remove. There are things, as you can see down here at the bottom, that drywash resin really won't remove, at least not other than the effect of, as resin, which acts as a filter, gets coated with crud, whether it be unreacted oil or glycerin, whatever it might be, it acts as a filter, actually a very effective filter. And so you do actually remove some of those things that are not directly removed. But you can't depend on the resin to remove starches. And I put taters behind that because that's where the starches are coming from taters. Some people call them potatoes, but I grew up calling them taters. There's three major ways. There must be a million different ways, but there's three major ways to remove the contaminants or the byproducts. Water wash, absorbents, which would include magnesium silicate and wood fiber, and then of course dry wash. And so what I'm going to talk about today is specifically dry wash with ion exchange resin. But as you'll see as we get a little bit further into the discussion, that all of these ultimately can be used in some combination to get the job done. Now, quick question for everyone in the room. How many of you make now or have made biodiesel? Okay. How many of you water wash? How many of you dry wash? Okay. How many of you have used DW-R10, an ALX product? So our products are sold direct to the big companies from my company, sold through some distributors to the smaller plants, and a company called Utah Biodiesel Supply, you may know of that company, is one of our distributors. And up until very recently, if you went to his website, you couldn't find my product on there. He's actually, we're polishing right now that part of it. But at any rate, there is experience here with dry wash. Unfortunately, even in some of the big plants, people try dry wash and it fails miserably, and they go back to water wash, or they go to wood fiber only, or to magnet salt, whatever it might be. But obviously it can be applied and it can be very effective. It is a very good option, and we can talk, as a group about why it may be the right option for your operation. Okay, when we talk about dry wash with ion exchange resin, one of the first questions that comes up is, what is dry wash resin? And essentially, all of the dry wash resins out there start with the same copolymer. And when we say copolymer, we're talking about a plastic. You really don't see much plastic that's not compounded. Styrene coffee cups are pretty much straight styrene, and it has a certain mechanical properties. But when you cross-link styrene with divinyl benzene, which is another plastic, you make a very, very, very tough bead. I sell 20 to 50 million pounds of beads that are styrene divinyl benzene beads to the oil and gas industry for horizontal drilling as a mechanical lubricant. And those beads, and this is the silliest thing you'll ever hear, the different ways they test the ability of the beads to stand high pressure, but people make claims for 18,000 psi, all over the map. But the bead itself, the copolymer, is extremely tough, and it's also insoluble in methanol and in strong acids. It's really a tough plastic. Now, what happens in the process of making these little things at the bottom, which are the Drywash resin, is that the beads themselves are made from monomers, and it's really done in an emulsion, and that's the reason that you end up with a perfectly round bead. And then to put the charge in the bead, you have to expand that plastic, and you use there's some solvents that will do that. The beads are expanded to more than twice their original size, and then the functional groups are substituted into the plastic while it's expanded. And the amount of expansion is such that when the solvent's taken back out and water ultimately during the functionalizing process replaces it, that the beads, the wet beads, will have more 50 to 60% water content by weight. So now this process of making the bead before it's functionalized, there's two different routes, two different types of beads that are made. One is called a gel type bead, and as you'll see a little bit later, gel is an extreme misnomer, because people, when I think of gel, this is many years ago when I got involved with ion exchange resin, first thing I thought about with gel resin was, good heavens, that stuff must be squishy and easily destroyed. But that's just not true. Tough material. So there's gel type resin, and then there's macroporous. Macro, big pores. And there is one brand of ion exchange resin that is fairly commonly sold that is a macroporous resin. Todd?
Actually, I'm confused, which is where I show my lack of chemistry background. But we've also been looking at the cationic flocculants. To me, those look like a gel, and they seem to function similarly in some areas. And but they are liquid. And they're put into. Now, is that not considered a resin? Is it not considered a resin because of the base structure you're talking about, or how would I categorize those flocculants and coagulants?
Okay, that's a great question, and it's an excellent way to look at this, because I sell to the chemical industry and the oil industry through another company that I'm a partner in. I sell tons of polyacrylamides, Dadmax, and all types of polymers that are used for separating liquids and solids. And what I was talking about, a polymer is basically a carbon chain with functional groups hanging off of it. And it's a liquid. It's a liquid that has very, very strong charge, and of course there's many different varieties of these polymers based on what you're trying to flocculate. But the functional groups on a cationic polymer are very, very similar in one respect to the functional groups that are inside that resin. And there's cationic and anionic polymers. So one way of looking at this is that resin is a solid form of that cationic polymer. It's in a ball.
Absolutely.
It's in a ball. And we look at another picture here, and this is a picture of the beads. Now, this is gross commercialism on my part to have DW-R10. I blame Graydon for this. But that is kind of a look at the beads. And those beads, all, or virtually all of them, are between 350 and 500 microns in size. And that's really a very important characteristic, because I heard on the presentation from the gentleman from Argentina, he was talking about, pressure drop across his bed. You put those beads together, going back to this other picture, if they're all exactly the same size, can you see this picture well enough to see that when spheres are in another container and the spheres are touching, that there is a space between each one? And surprisingly, if you do the math, that works out to be 34% of the roughly. It depends on things, and there's some really higher math that are used to calculate, like if you had nesting. Well, if you fill this room with basketballs until you couldn't get another basketball in, you could say that room is full. But then if you came back and you could throw in marbles from the top, they'd all roll down between the basketballs. You can put a lot of marbles in there. And then when you got all the marbles in that you could get in, you came back and started throwing sand in, you could get a lot of sand in that. Same phenomena with the resin. If you have a big variety of sizes of beads in that resin column, you will have nesting. You'll have little beads that are sitting in here between the big beads, and the net result is you're much more likely to have a pressure drop issue. And we'll talk later about the whole issue of getting flow through resin. But
I've got a question. The bead diameter. Where in my house we have a well, but the well's got very hard water, so in order to make soaps work for washing, we have to put it through a water softener. And that water softener has a bead system in there where the beads in there are much larger than this, and those beads are taking up the harder minerals and what have you before we add salt into this thing to try and soften it. So is it specifically your product for design with a much smaller bead diameter than what I see in this other system for softening water? It's almost like almost a third of the size of these other beads that we use.
Well, ultimately, after our dry beads are expanded, they're bigger than the ones in your water softener. One thing you have to remember, when I said in this picture before that those beads are anywhere from 350 to 500 microns in size, that's dry. When they're fully swelled because they've absorbed methanol, glycerin, water, they're going to be 750 to 1150 microns in size, and they would look bigger than the beads in your water softener. Now there's a real similarity between the beads in your water softener and these beads, in that those beads are in the sodium cycle, meaning that they're regenerated with sodium chloride, and sodium resides, it's nesting on that functional group. These are in the hydrogen form, and they're regenerated with H2SO4 or HCl, or you can use other acids as well. But this series of pictures, and I apologize if you can't really see them very well, but they're at different magnifications of the resin. And this is the highest magnification. And that's a really, really close look. Not done with your standard microscope, believe me. But most people that look at that first picture on the left, or they look at the resin, and it's just not possible for them to imagine that the bead is that porous. But trust me, it is. Well,
not only is it porous, it's flexible. I mean, it's interesting because you start this out saying you've got this polymer that's really, really strong, really tough. You can use it as a mechanical lubricant, and then it's still flexible, it expands, it does all this sorts of things.
Yeah.
Relatively low pressure.
Yeah, it's surprising. Well, this is meant to represent the functional group that's on the resin, and when the resin is fully regenerated in the hydrogen form, it has a little hydrogen, you might say, just for purposes of imagination, sticking on there. Well, if you split soap or if you remove catalyst, you will trade that hydrogen for a sodium or a potassium. Now, unfortunately, every time you do that, you convert that resin. People think, well, the resin's spent. It's not really spent in the truest sense of the word. It's converted from the hydrogen form to the sodium form. It could be regenerated with strong acid to get it back to the sodium form, hydrogen form. But trust me, you don't want to do that. And I'll tell you why. I've done it in my plant. And my plant's a zero discharge operation. You know, we go nuts. We try to send our dumpster out empty. You know, we don't discharge anything to the air, to the ground, or the water. But we have to go to some pretty dramatic efforts to do that. With the resin, to regenerate it, you have to get the crud out, which takes a lot of water. And ultimately, you can regenerate with acid and get some of the functionality back. But you end up with a lot of dirty water, a lot of dirty acid, and you end up with partially regenerated resin. And in the long term, you're better off starting over. Better off starting with fresh acid, fresh resin.
So, just to go back, one of the reasons that we used to try that, we used to try to generate a resin. And one of the reasons we went back to Drywash is we did this in parts. We've gone through the facility, I told you, we're trying to find the cheapest, lowest cost to get the stuff spent. But so we do Drywash, we have to. But from our perspective, it was very difficult, so we couldn't figure out a way to actually get good results. When we were told repeatedly early on, oh, we generated, it would be great for you, the ROI's here, it never worked out for us.
Yeah. Well, it's interesting, and in the biodiesel business, and trust me, it's this way in every business I've been involved in, the word regenerate means different things to different people. To get the absorptive capacity of the resin back, you can wash it with methanol. And what washing it with methanol will do is it'll re-swell the resin, and because of the differences in the concentration of resin and the glycerin in that washing process, you'll wash out the glycerin that's absorbed inside of the resin, and you'll wash out some of the free fatty acids that are inside the resin because the soap went into the resin and was split. The sodium was taken off of the soap, and then you have free fatty acids. But with the methanol, you can wash it out if you do it right. And by doing that, you can ultimately get to the economics that we're going to talk about later on, where we compare economics of water wash and dry wash and magnet salt.
You said you're using a gel. You had left up before you had a gel and macropore, so your resin's a gel resin?
Our resin's a gel. We do make macroporous resin as well. But it's used in some different circumstances.
You find the gel resin? I mean, just
yeah. I have 3 plants right now that are doing catalyzed esterification, and their esterification catalyst is macroporous resin. I have several plants that are using a macroporous resin that we provide to improve cold soap numbers, cold flow. And that's working extremely well, but it's not ready for release to the...
Sorry, don't interrupt, but so this particular resin, what is it that you would be trying to isolate? What is it that you're trying to wash out?
Okay. This resin will remove polar compounds. When it's in hydrogen form, it has a tremendous affinity. When it's exhausted in the sodium form, it still has an affinity, but a much lower affinity. So you'll reach that point of diminishing return for using the resin, and that's when you have to replace the resin. But what this resin will remove, it'll remove glycerin, glycerol to within ASTM specs, or whatever.
Now, is that removal an ionic exchange, or is that just some adsorption?
It's an absorption and an adsorption. It's literally, depends on temperature, but literally the glycerol goes into the resin. The soap that's soluble, and we'll talk about micelles a little later, goes into the resin. It will remove methanol, but we're going to talk a little later about why you don't remove all the methanol, and you don't want to remove all the methanol at that point. But
any impact on sulfur?
Interesting you ask that, because
I do animal fats and I'm going to end up with higher sulfur content.
okay, I can tell you that Flint Hills Resources, which is owned by a big oil company, makes 15 million gallons a year of biodiesel in the Dallas area, all of it from beef tallow. And there's a little bit of pig tallow that gets in there every once in a while, but they never have a sulfur problem.
Okay.
And they are the most analyzed product on the planet, because all of their product goes into Flint Hills gasoline, which is sold, you know, I mean it's an internal thing.
Sidebar, shameless plug for industrial course. We actually have a sample of their lung material that we were working on to try to solubilize just a period of time. It's a byproduct of their process. Very difficult to deal with very shit. So I won't say they were listed, we were listed to some more people.
So are they using your resin?
But when you talk about sulfur, this product will not remove sulfur by ion exchange. Okay, but sulfur and silica are two molecules that kind of defy, you know, common chemistry. If you've ever gone into a petroleum refinery where they remove sulfur from sour crude, and then some of it ends up in their wastewater, and you look at wastewater and you see a pearlize, some really weird looks in the water, you know that sulfur that is in a kind of a different state. So ultimately, if you remove any sulfur, you remove it because the sulfur was reacted with something else and became insoluble, and you removed it by adsorption or by it being trapped in the crud that's on the outside of the bead. And we're going to talk about the crud factor a little later. Someone probably should punish me for putting unsuponifiables there, but my customers use terms a lot of times that maybe aren't really a real word, and so I use that word too. I mean, I say, hey, when did Rome speak, you know, like the Romans do? But getting over to, I think the question was asked.
I'm sorry, Brian. You made a distinction between regeneration, like you said, would you call that reactivation then, putting the active site back on?
Reactivation or washing, you know, you know, there's different ways to look at it, but what happens when you look at the bead there, when you start flowing through that column of beads, let me see if I got a better picture to try to illustrate this later on, but you start flowing through that column of beads that are packed. Look at the picture on the left over there. The process stream that's flowing at that point has soap, some of that soap's insoluble. Soap has, you know, ends, and it forms micelles, it forms globules, and so some of it is physically filtered out by the resin, simply because in a gallon of that resin there are 59 million beads. That's a rough number. If you did the surface area for those 59 million beads, and I've done the calculation, it would amaze you how much surface area. In other words, if you took those beads and you let's peel them like an orange, spread that out, tremendous amount of surface area. So as you flow through the resin, the glycerin, some of the other stuff goes in, the unreacted oil, you know, triglycerides, you name it, they stick to the outside of the resin. And then that makes for a sticky filter. It'd be kind of like if you put syrup on the outside of basketball, you know, it literally, the resin becomes sticky. Now, when we talk about regenerating or washing or restoring, you know, whatever you want to call it, the resin, you put a methanol in. Methanol in a high concentration, being polar, gets absorbed in the resin. The resin swells very rapidly, and you end up bringing glycerin out, and it's kind of like you were pressure washing the outside of the beads from the inside out. Unfortunately, you don't get all the crud out or all the crud off. And in fact, it's not at all common. I've seen it in some huge plants where their wash procedure, they ended up leaving crud on the resin and in the resin, and then they put that, when they put that column back in service, that crud goes right into their process. So it would be a little bit like...
Because it's moved to the outer layer from the inside, is what you're saying?
Well, because you still have glycerin, and you have some beads that didn't get washed. You've had channeling. You didn't completely flood the bed with methanol. You know, there's every way under the sun. It'd be a little bit like, you know, washing clothes with, you know, a tenth of the amount of water that you needed, or not, you know. I'm sorry. Yes.
In relationship to filtration, what would you say? Can you use 1 gallon in all of your towels? That's what you said, 1 gallon in each towel?
No, and I confused it. What I said is that 1 gallon of the resin holds 59 million beads. But let's talk about the towers, and that's a good point to discuss this.
So the reason why I'm asking this question is, in terms, and each of the tower that you recommend, what would be the actual configuration in terms of micron filtration? For example, this is a filter that can take out 5 micron, 100 micron, 50 micron. What micron would it stop from passing? What size? What is the micron size? For your filtration, for your towels that you use. For example, the dry, Mark, do you make these dry? The dry is talking about these towels?
Yeah, we make a dry wash system. We use other resins, but we could put yours in there and it would just filter through.
Okay, so what micron would not pass through? What micron?
The actual beads?
What would not pass through the beads?
Yes. When you go out, for example, you have dirty water coming through, and you said, okay, at the end of it, you won't have anything going through exceeding this micron. So
okay.
Is there a size that the amount of micron? The reason why I'm asking this question is, if you're going to sell to people in cold weather, a lot of the reason why it's a problem is the solid material that's in it that causes clogging. So will this remove some of those material that cause clogging in low temperatures?
Yeah. It will remove some of the materials that cause clogging in cold weather. But one thing to remember about the resin bed, even though there is some filtration that occurs, the beads are large enough that it's not conventional filtration from the standpoint that you've got a filter that stops things above a certain particle size. The resin has to be used in conjunction with proper separation of glycerin and soap ahead of the resin, and then after demethylation, then you know, you still need to filter some solids out. There will be solids that will pass through the resin, but we're gonna talk now about. And we're gonna get, I think, to answer some of your questions, we're gonna get through this some. I'm sorry. Go ahead.
I just back on that first slide. I just have a question on some of the functionality of the resin. You mentioned it can break up soap, like exchanging a hydrogen for a sodium or potassium. Mm-hmm. What happens to the free fatty acid as a result of that process?
Those contribute to the acid number for the product.
Okay, so it just goes through.
Yeah. And one of the things I hear sometimes from people is, well, I don't use resin because I'll always bust my acid number on my biodiesel. Well, all these big plants that I mentioned, they run. I mean, I've got customers running straight canola, straight soy, but I've also got the vast majority of my customers run poultry fat, pig lard, animal fat, yellow grease, combinations of the above. I've got some guys that are running some brown grease, you know, that they're blending in, some intentionally, some unintentionally. And, you know, depends on how clean the truck was that hauled their yellow grease in, you know. But ultimately, the acid number, I've only seen the acid number be busted on these big plants once or twice in the last year. And in both instances, there were contributing factors, meaning that they had some other weird things going on. Instability of their finished biodiesel, because they did have some brown grease in, and they ended up with oxidation rates that were incredible, or they ended up with some water in their storage tank, and they had, you know, all kind of weird things that happened. But ultimately, if you can get your soap under about 2,500 ppm, then you won't bust your acid number on your fuel. Now,
2,500 ppm going into the resin.
Going into the resin. Now, you don't want to be that high, and we'll talk about why you don't want to be that high. But yeah, the lower the better. Yeah, the lower the better. But you know, let's talk about one of the big advantages of dry wash is simplicity. You know, we talked about how a typical continuous flow plant works. The typical continuous flow plant has reaction, and some of them do first reaction, intermediate settling, and second reaction, but it ultimately is the same thing. They go from the reactor, they go to physical separation or settling, and big majority of the large continuous flow plants still rely simply on settling. But I've got an increasing number that are now using coizzers, some that use centrifuges, which really don't work that well for getting, you know, the glycerin, everything down to the levels that we want, where we want to be going into the resin. And we're going to talk about, you know, different ways to improve that separation, the physical separation of the glycerin and the soap before you get to the resin.
Yeah, especially since the challenge for us is the demethylation. That's what we want to do. We want to get better glycerin drop out, so we are trying to demethylate earlier in the process.
Yeah.
And so that's interesting.
And that's right. This is a good time to talk about that. Most of these big plants that have this very simple process have between 2 and 4% methanol going to their columns. And until you get up above 4%, that's really not a problem. Even I've seen plants that run 6%. Now, there are plants that have two-stage demethylation, where they take out some of the methanol before they go to the resin columns. But if you're going to do that, you got to remember that the reaction is reversible. You know, take triglycerides plus methanol and you make methyl ester. But if you have no methanol and you have glycerin and methyl ester together, the reaction will go backwards. You make triglycerides. I mean, it will back up on its own. It will seek equilibrium, literally. So if you don't have some methanol at that point, you take that risk. And how much is enough? I don't know, but I've seen it happen. Particularly on people that are running batch type operation and they try to take too much methanol out before they go to the resin. And then they have settling, or they have a long residence time. Now,
oh, I see. Because you've got, basically what you're doing is now you're passing it through somewhere you've got a metal-based active site. So I got you.
yeah. Now, the resin actually works better if there's some methanol present. And I've heard about 5 million theories as to why that's true. I'm not sure which one's correct. But I think personally it has to do with the methanol reducing the viscosity of the glycerin and allowing the glycerin to be more readily absorbed into the resin. That may be it. It may be that it partially swells the resin, which helps with the absorption. I don't know for sure, but I just know that it's a ratio thing. I have a lot of big customers now and quite a few water wash plants that use this exact same resin after demethylation, after water wash, demethylation, and they're ready to go to storage, and they have a resin column. And what they're doing is they're already in spec on their fuel, but maybe they're pushing it a little bit on water content. Maybe they still, they want to get the glycerin a little lower. They want their product to be more stable. They want it to be a better product. So after they've done water wash and they're in spec, they still go through the resin beads. And in that circumstance, because the glycerin levels and the other stuff's so low, you'll reduce the glycerin, you'll get the rest of the water, you'll actually absorb a little bit of methanol. This resin loves methanol. And the resin lasts in that circumstance a long time because the loading is so low. Now, even plants that dry wash will still use that same trick. After demethylation, they'll have another column, and then when the resin gets loaded up, because they can't wash it with methanol there after demethylation, they just wait till the resin gets loaded and they see not a delta across the resin, it's starting to slip. Then they'll take that resin, they'll put it in the front end, they'll wash it with methanol, and they'll use it ahead of demethylation. So they're just moving the resin back to another place in the process. So if I had diesel pickup truck, my own diesel pickup truck, and I had stored biodiesel for a week, a month, or whatever it might be, I would run it through some resin before I put it into my truck, because as everyone knows, methyl ester loves water. It'll take water right out of the air, and the methanol that remains in it will help with that process. Now, as I mentioned, most of the plants that use dry wash use the dry wash before demethylation, and most of those use a really simple demethylation or ADU, I'm calling it their ADU unit, but it's just a pack column with a vacuum pump, and they run a little bit of air or nitrogen in, counterflow to it, and they strip it in that manner. And typically they have a heat exchanger to heat the methyl ester up. Typically it's coming out of their settling tanks at 110, 115, then going through the columns at 110, 115, and then going to their demethylation. They heat it up typically to around 200 to 215. And then, like I say, a little bit of counterflow, a very, very small amount of counterflow air helps to strip the methanol, and then they condense that methanol. They have a condenser after their vacuum pump, or in some cases a little condenser before and one after, and then they recover that methanol and put it back at the front end for transit certification. So that's the way most of them operate. Now, they all operate with a pack column, 99% of them in a downflow configuration, flowing down through the resin. And
Why downflow?
why downflow? That's a good question. How many of you have ever been in a fructose sugar plant? Ever been into an ADM or a Cargill plant? They use chromatographic separation to, and you know what a chromatograph is. Chromatograph uses something to slow down flows, based on the, the differences of the molecules. And what I believe happens, the reason upflow doesn't work, is that when you're flowing upwards through the resin, the glycerin is heavier and it's more polar than the methyl ester, obviously. And I believe that it slows down as you go through upflow,
And so literally you get better separation initially, but eventually for some reason the thing hurls. Anybody seen the movie Wayne's World? You know what hurling is?
We do upflow, so I know exactly what you're
saying. Okay, so and then the other thing that happens, it happened at Falmouth, Kentucky in a big biodiesel plant, is that some of the soap gets all the way through the bed and some of the resin floats and the outlet filter plugs. So I've tried it both ways in the lab, and ultimately I can tell you, if it were mine, I'd do it downflow. It'll work either way, but downflow is better. And depending on the level of contaminants, you can go faster than 3 bed volumes per hour, but that's what most everyone runs, and that's the best. That's about the best place to be. Okay, all right, I'm gonna have to move fast now. When we say 3 bed volumes per hour, if your column, and this column came from this pictures came from Utah Biodiesel Supply. Graydon has these columns available. But if your column holds 20 gallons of resin, then you should be able to run 60 gallons of biodiesel through it per hour. And as long as you're washing properly, you should come out with good fuel on the other end. This is typical configuration after physical settling, is to go through a lead column, then a lag column, and then to methanol removal or recovery. Now, why lead lag? The reason is really pretty simple. You want to run your resin until it's done. You don't want to throw away good resin. You don't want to wash it before you need to. Well, if you run lead lag and you test after the lead column and before the lag column, then you're much more likely to catch it before you put bad fuel to your fuel storage, or before you send fuel that has soap and glycerin in it to your demethylation column and create in that demethylation column a huge mass of slime. And trust me, when you take all the methanol out of biodiesel, it still has glycerin in it, it makes slime. So that's the typical, and then the standby column. Now you don't have to have, if you're batch, you don't have to have a standby. You can wash your lead and your lag, you know, in the downtime, but
what are you measuring for? You said if you measure after the lead column,
yeah,
you see it goes bad. What are you measuring for?
Most people measure for soap, simply because it's easier to measure for soap than it is to measure for glycerin. And some people do it by the eyeball test. When they see the turbidity of the fuel, the cloudiness of fuel going up, then they wash their lead column.
You mentioned demeth was after the columns, so you said 2 to 4% is what you're targeting going into the columns to get effective?
Yeah, I mean, if your soap and glycerin are real low, you can go in with 0.1%, as long as there's a ratio between the soap and glycerin, but typically it's 2 to 4.
Real low, what is that, like 300 ppm, or, I mean, what are you talking about for real low going into a column?
Yeah, real low would be, say, under 200 ppm of soap. That'd be real low.
4% is what's left over in the reaction.
At 9 minutes.
Yeah, and the reason for the 2 to 4% is that's about the excess methanol that most people run. You know.
So with the configuration of the 3 tanks, you're essentially taking your biodiesel and you're putting it through your dry wash twice.
Yes, flowing through 2 columns.
Okay.
In series.
In series, yeah. And after this, if you measured the biodiesel at the end of the second pass, you will have gotten...
Inspect. You don't have to do anything else to it but take the methanol out. And someone mentioned to me that in South America that they don't take the methanol out. They just leave the methanol in and it doesn't hurt the engine. So something to think about. But I guess you got to have the, you know, you got to know your engine. But
affect the timing though, won't it? I mean, it
well, yeah,
it won't pass spec. I mean,
it won't pass spec, but that's just something I was told very recently that they don't take the methanol out in that part of the world. In the process, and I'm running out of time, I apologize if I rushed through this last part, but in the process, a lot of people use, if they have really high soap, they'll use wood absorbent before the dry wash. And that does help if you've got really high soap levels, because the wood will do a great job of taking out soap, and it'll get some glycerin. But ultimately, you can cut your costs if you got a real soap factory going. Now, again, at the lead column, what most people do is they'll wash when they see the soap slippage get up into 25% of the inbound. So in other words, they got 400 ppm of soap coming in, they'll wash their lead column as soon as they see 100 ppm of soap coming out of the lead column. Then they'll wash that lead column. And after the lag column, obviously they want their soap and glycerin to be, you know, in spec. Now, when we talk about washing with methanol, we could talk for hours about the best way to do that, but I think I'm gonna have to kind of get to the wrap up, and I'm gonna email everybody on this email list so they'll have my contact info. And Graydon's done a great job of getting some of the information on his website that answers some of the questions. But when we talk about the cost comparison, guys, I've seen an incredible variation of water wash costs. For a big plant, most of them will say around 6 cents. And I don't think we have time to debate that one. I do know that with Magnesol, typically you're 12 to 14 cents a gallon for Magnesol. With dry wash, one reason that you know, we take care of so many of the big plants is that they are meticulous at watching the gallons they process per pound of resin they use. And that's partly because of how we got into the relationship with them in the first place, by originally guaranteeing that we would equal our competition. And so they watch it like a hawk, and when they have a problem, typically they call and say, Rod, you screwed up. And then a lot of times I have to go to the plant and say, well, you know, hey, your poultry fat's 15% FFA, you know, guys, and you've been at 2%, so why are we surprised that we're using more resin? But anyway, with dry wash, I can tell you, if you buy some of my product from Graydon for $8 a pound, the median number for gallons per pound of resin is about 150 gallons, and that works out to about a nickel a gallon. And when you consider your time for water wash, it's really not a bad number. You know, really isn't.
So converting this back into volume, how many pounds in a gallon?
Yeah, right.
Okay, and we sell resin by pounds, and so what I'm talking about is using 1 pound of resin to treat ultimately 150 gallons. To produce 150 gallons.
And the question is, in a let's say a 10-inch column.
Yeah, I was
you know,
thinking
how much pounds is in there?
Physically, to charge a tank, a tower, how many?
Specific gravity of the resin.
Yeah.
It's on our website. You can look at it. So
Depends on how fast you want to run, because it's really all about bed volumes. Now I've got a spreadsheet that I'd be happy to send all of you guys a copy of that really does a great job of putting this all into perspective. How much time do I have left?
About 3 minutes.
Whoa! Okay. Let's talk about mileage. How to get the most out of the mileage. Like the question was, you know, it's my money. I don't like throwing my money in the trash can here. So. And this slide, I apologize. I should have blown this up bigger, but the typical is 150 gallons. That's the median number. The range is 120 gallons to 220 gallons. The factors that can affect life are soluble soap. When you get into animal fats, animal soap is let's see if I got a picture of it here. Animal soap is less soluble. The soaps that are made from that particular fatty acid are much less soluble. Sodium soaps are less soluble than potassium soaps, but ultimately if you give soap a chance, it'll form a micelle or liposome, or a bilayer sheet as they call it. I've seen that on top of resin columns, particularly with people running tallow. And if you can remove the soap by physical filtration instead of by ion exchange, you're better off. But ultimately, the best way to get the maximum mileage out of your resin is to do a good job on your reaction, do a good job on separation, and then use the right methanol wash procedures. Let's go, because I'm running out of time, let's talk a little bit about talk about one thing that's discussed on Graydon's website. I've got some smaller customers and even some medium-sized customers now that are doing a 5% pre-wash before they, as part of their, you know, as at the end of their reaction, before they go to set it. And then they go through their resin. And that's working extremely well for those folks. And what we discovered as I started experimenting with a couple of plants that are close to me, we discovered that if we use decationized water for that pre-wash, that it does a much better job and you make less mayonnaise. When I say decationized water, for those like John, you know, we talk about the water softener that takes out just the sodium, I'm sorry, the calcium and the magnesium and exchange it for sodium. The decationized resin, which is strong acid resin, you take out virtually all the cations. You leave the anions. The pH of the water goes below free mental acidity. And because you're not risking making calcium soap, which is tub scum, bathtub scum, you know, you're much better off. So these folks have found that they use the decationized resin, and that's something that I'll be making available through Graydon's website, and it's really simple to use. Really simple. Some of the bigger plants and some of the smaller ones now are going to coalescers. How many of you have ever seen a coalescer or know how they work? Coalescer, same word as coalition, they're related. It just means getting stuff together. And if you look at this is a typical oil field coalescer. And you have a pad, and it's a little bit like a reverse static mixer. You start out with finer mesh, and you go to more coarse mesh. One reason that physical settling doesn't work very well is that you reach a point where you've got so few of the droplets of glycerin in the volume that they're not colliding often enough and they're not falling out. With a coalescer, it just speeds that process of collision up. And the downfall of coalescers, Pall, P-A-L-L, most of you heard of them. They brought out the first coalescer for biodiesel, and it plugged up within 3 days because of soap and unreacted oil. So people that are doing it successfully now are using their spent dry wash resin ahead of their coalescer to filter the biodiesel. It needs to be spent resin, and it works great. And then it's a simple homemade design coalescer, and we use stainless steel wool as the coalescer pad. And that's cheap and easy. So we're talking about a homemade thing or something, again, that Graydon will be selling on his site pretty soon. That really helps. So, okay. Decationized water, guys, we just don't have time to talk about it, but there'll be some discussions of it. As far as the questions, I'm woke and I can read your mind, so I know what your questions are. So I got all recorded.
But luckily you're out of time.
And, but I'm out of time, guys. Thank you.